Greetings from EPG Pathshala. We discussed in module 2 how to work around with symmetric cipher. Now we are going to focus on heel cipher, that is again part of symmetric cipher. When I say symmetric cipher, it clicks to you that the key used for encryption and decryption are same. Then how do all these algorithms differ? The algorithms differ the way in which they process the plain text. In the heel cipher, we are going to work on key that may be a 2 by 2 matrix key or 3 by 3 matrix key. How this algorithm works, that is what I am going to cover throughout this module, and then at the end we are going to evaluate the strength of the heel cipher. Now I will start with multi-letter cipher, that is heel cipher. We will be using M, that is a square matrix. We will be denoting inverse of this square matrix as M inverse. M inverse, if we multiply matrix with its inverse matrix, we are going to get identity matrix. Identity matrix is nothing but where all diagonal elements are going to be 1, rest of the elements are going to be 0. So it says M multiplied by M inverse, that is a key point in our algorithm. It would give you inverse identity matrix where only diagonal elements are 1 from upper left to lower right, all other elements are 0, as I already explained. Every time inverse of matrix does not exist. So once again the point to emphasize is, for this algorithm we can work around with a matrix whose inverse exists. For example, I want to show you that M inverse gives you identity matrix. For that M, we have considered M to be in the rows 5 and 8, in the second row it is 17 and 3. We have calculated M inverse mode 26. So here secret is, why did we use mode 26? Because once again we are going to deal with English alphabets and we are going to number them from 0 to 25. So we want our result to lie between 0 to 25. Now M inverse comes to 9, 2 in the first row and 1 and 15 in the second row. How this M inverse is calculated, that we will see in the next slide. This slide focuses on multiplying M with M inverse to get identity matrix. And why we are bothered about this, because heel cipher can only work on the matrix which has inverse matrix, and the idea is M multiplied by M inverse gives you identity matrix. So you all know the matrix multiplication. The row will be multiplied with columns. First row of M would be multiplied with the first column of M inverse. The second row would be multiplied with second column of M inverse. Then comes second row with first column and second row with second column. So now we have got 4 elements back. Check the value of the elements: 53, 130, 156, 79, and what I said in the beginning, our numbers should be between 0 to 25. So we need to do mode 26, which gives us the identity matrix. You can check the diagonal elements are 1, rest of the elements are 0. Then I said in the previous slide how to compute inverse of matrix, that we will check. So computing inverse of matrix, first step involves find the determinant. To give you an example how to compute determinant for 2 cross 2 matrix, name the elements as K 1 1. suffix 1 1 indicates that the element is lying in the first row and first column. So, no wonder if I say K 2 1 with a suffix 2 1, yani it lies in second row and first column. To find out the determinant, you need to multiply the diagonal elements K 1 1, K 2 2 minus another diagonal elements K 1 2 and K 2 1. For 3 cross 3 matrix, you have to consider the matrix arranged in the elements way. K11, if you are considering, omit that row and column. K11 would be multiplied with diagonal elements K22, K33. Other diagonal elements are K23 and K32, and they go ahead with a negative sign. Now, which other elements are there in our equation? If I consider K21, it goes with which other elements? So, what magic I taught? Omit the row and column. So, K21 would be multiplied by K32 and K13 and minus K12 and K33. So, here it is. So, now you can easily check for K31 what happens. Omit the row and column containing K31 and then check the rest of the elements. They come as K12 into K23 minus K13 into K22. So, this is how we have computed the determinant for 3 cross 3 matrix. I think you are in a sequence. First, find out the determinant. So, now there is a need of calculation of inverse matrix. The first condition for calculating the inverse matrix is determinant should be non-zero. You have it in mind, we are working on square matrix. So, to compute inverse of matrix, the equation says given A, its inverse is denoted by A inverse I j. Suffix I j says I rows and j columns. To compute inverse, the equation says find out determinant of A, take its inverse, then its minus 1 raised to I plus j. Exponent is I plus j. Once again clear, I is number of rows, j number of columns. Then we need to check dji. D represents subdeterminant obtained by removing jth row and ith column. What you need to keep in mind, we started with A, I, j, that is I representing row and j representing column, and when we went ahead in the equation, it is D of ji, yani j becomes your row number and I becomes your column number. So, if you look at my slide, I want to find out determinant of given matrix, that is row wise it is 5, 8 and the second row it is 7 and 3. Now, to compute the inverse, we need to do minus 1 raised to I plus j. So, this time A 1 1 is in our mind. So, I is 1, j is 1. So, minus 1 raised to I plus j, that is 1 plus 1 2. So, it becomes 1 because minus 1 square is 1. What you need to do now, d of j I, j is 1, I is 1. Subdeterminant is obtained by removing the row and column in which the element is lying. So, if you have focus on the slide, what you can do is I is 1, j is 1. So, if I find out subdeterminant, in that case j is 1 and I is 1. So, remove the first row and first column. So, you are landed up with 3. So, 3 goes in the first element, 3 goes as a first element. Now, if you are clear, check the second element. What should come in the second element? So, now we are computing A1, 2, first row and second column, but when I am going to compute subdeterminant, it becomes Ji. So, I need to remove the second row, second row and first column. So, what we land up in is 8, but this time minus 1 raised to I plus j is 3, so minus 1 raised to 3 gives you minus. So, element comes to minus 8. So, this is how we have computed A11 and A12. So, now apply your mind to compute A21. Now clear, I is 2, j is 1, but when I talk about subdeterminant, it becomes ji. So, it becomes d of 1, 2. So, what we need to do? We need to remove the first row and second column. So, we land up with 17. Once again minus 1 raised to I plus j. So, it is 2 plus 1 3. So, minus 1 raised to 3 gives you negative value. So, it becomes minus 17. So, now for the 2 by 2 matrix, the last element is to be computed, that is A22. Now clear, I2, J2. So, what you need to do is remove the second row and second column. So, which element is left? 5. Minus 1 raised to I plus j, that is 2 plus 2, that is 4. It gives you positive value and we have a value 5. So, we will keep 5 as it is. So, this is how inverse of matrix is computed. Now, Hill cipher. This is a basic thing, basic mathematics which is followed in Hill cipher. The Hill algorithm has input, that is m successive plain text letter, and output is m ciphertext letters. If we have m inputs, m linear equations should be built. Each letter is assigned a numeric value A0, B1, Z is 25. If 3 plain text characters are taken, then to solve this 3, we have to take 3 linear equation C1, C2, C3. How they are built? Key is given of 3 by 3 matrix, plain text are given, so we need to consider 3 plain text. So, to compute ciphertext 1, 2 and 3, P1, P2, P3 should be multiplied by key and modulo 26 should be taken. So, Hill algorithm has an equation called, to compute ciphertext, plain text should be multiplied with key, modulo 26 to be given. If key is of order 3 by 3 cross matrix, then ciphertext should be of length 3 and plain text should be of length 3. You are clear how to assign numeric value to the English alphabet. A should be assigned 0, B 1 and Z 25. Suppose for example, we have plain text called write, W-R-I-T-E, and my key is given, key is shown on the screen. Group 3 letters together because my key is of 3 by 3 matrix. So, one character is to be added because write contains only W-R-I-T-E 5 characters and we need 6 characters to deal with. So, we would add any character, this time again X. The reason is X is used few times in English language. So, first 3 letters of the plain text are W-R-I, which has a numeric value 22, 17 and 8. Second 3 letters are T-E-X and their numeric values are 19, 4 and 23. So, once we are with a numeric value, the only thing left is how to multiply these 2 matrices. Our equation is P, K mod 26. P is a plain text, so take 3 letters of the plain text, that is we took W-R-I, that is 22, 17 and 8, and key is given 3 cross 3 matrix. Let me remind you, when you take a key, what the key should have its inverse, because when we do decryption we would be using the inverse of the given key. Matrix multiplication, how it is performed, once again let me just remind you, row should go with the first column of the key. So, 22 multiplied by 17 plus 17 multiplied by 21 and 8 multiplied 2. So, that would give you the first ciphertext character for 22. Rest of the things you can repeat. 22 multiplied by the second column first character, that is 17, 17 by second character, 8 by third character. So, that would give you the second cipher alphabet. And now you are clear about the process. Take the 8, multiply it with the third column of the key matrix, and you are landed up with the third character of the ciphertext. So, if I do matrix multiplication and addition, I landed up with a value 747, 696 and 619. Those values are greater than 25. So, take modulo 26 and you will land up in 19, 20 and 21. That gives us the character T, character U and character V. So, we started with W, R, I and the ciphertext corresponding to that is T, U and V. For T, E and X, the same procedure is repeated. Put the numeric values for T, E, X. Key remains the same for all the operations. Do the matrix multiplication, land up with a value. If it is greater than 25, take a modulo 26 and you will get L, Z and S. Now, when we design any encryption algorithm, it should be possible that we should be able to decrypt it. In the Hill cipher case, the equation is, when you want to get a plain text back, get a ciphertext, multiply it with the inverse of key and do the modulo 26. Is Hill cipher secure? So, Hill cipher completely hides the single letter frequency. Why? Because we worked in a group of 3 letters or 2 letters depending on the key, whether it is 3 by 3 key or 2 by 2 key. 3 by 3, if you use Hill cipher hides 2 letter frequency, it protects against ciphertext only attack. Ciphertext only says when cryptanalyst is given only the ciphertext, algorithm is known but no plain text, no key is known and he has to derive the key. So, that is impossible if only ciphertext is given. So, Hill cipher protects you against ciphertext only attack, but it does not protect you against known plain text attack. Known plain text says that we are given the pair of plain text and ciphertext. So, in our equation P is known and C is known. Hill cipher's equation is P K mod 26 gives you C. So, if C is known and P is known, out of 3, 2 variables are known, you can easily derive the third variable. So, now let me elaborate how known plain text attack can affect our Hill cipher. The example is plain text Hill cipher is given, ciphertext accordingly is HCR, ZSS, XN, SP. This time we are going to work around with 2 by 2 Hill cipher. So, take first 2 characters of plain text, first 2 characters of ciphertext. So, that makes 7, 8, K is unknown, equation is known. So, P K mod 26 gives you C, that is 7 and 2. Next 2 characters are L and L. So, 11 and 11 multiplied with key mod 26 gives you R and Z, that corresponds to the numeric value 17 and 25. So if you prepare a equation, it goes like this: 7, 2, 17 and 25, that represents the C matrix. P matrix is 7 and 8, 11, 11, K mod 26. So you need to find out the inverse of the matrix 7, 8, 11 and 11. How to find inverse, that I already covered in the module. So if you try to get it, it would be 25, 22, 1 and 23. Once inverse is found, what you need to do is multiply it with a given matrix of plain text, and what you can derive is key. And once key is derived, rest of the communication can always be decrypted. So this is all about Heal cipher. So in this module we talked about Heal cipher. Heal cipher is also type of substitution cipher, but we tried to eliminate the frequency analysis by using 3 characters at a time, multiplying it with a key of, if it is a 3 characters, use a key of 3 by 3 matrix. If it is a 2 characters, use 2 by 2 matrix. Heal cipher works well with ciphertext only attack, but it does not work well with known plain text attack. The reason is clear. The equation is C equal to PK mod 26. If C and P are known, we can easily derive key. So still we have seen the ciphers which are not unbreakable. So in the next module, we will try to check how to increase the complexity of the cipher so that attacker cannot easily break it.